This is the Parker probe. Now, it's designed to pretty much be the Genesis 2.0. They're going to say that this probe is going that far, but I'm going to explain where the probe is actually going with common sense. This is the Genesis probe that was launched in 2001. It is literally what this Parker probe is. It's exactly the same instrument to do exactly the same thing. They sent it up hoping that they could touch the raw particle that GSI later in 2014 was asked to create to launch into a cell. They were hoping they could touch it first so they could figure out exactly what it is that's shorting out their systems and causing serious health problems to their astronauts. Well, unfortunately, when they launched it up, we only had our basic, we were past radio to digital, but that was the best that we could do. We didn't have 5G communication systems that used gamma technology, so we couldn't communicate in the fields of plasma that it needed to go into and touch to get to the sun's atmosphere, this raw particle. Now, when it finally came back into space, unfortunately, the thing was exactly as we predicted it would be in those fields. It was destroyed and it lost communications and all of its electronics on board failed. And so when it came back in, as you can see here, the parachutes didn't open and it crashed into Earth at a phenomenal rate of speed. Now, its whole mission was to be an enclosed system that was opened in deep space where the sun's atmosphere was and collect one of the particles in the plasmasphere at 6,000 miles up so that we could study that particle when it closed up and fell back to Earth. Now, as it crash landed here, you could see that's not going to be possible to study those particles now because it's exposed and all the particles here on Earth are now intertwined with those particles. The mission was scrapped and everything was pointless. We had to just pretty much move on. So for years we've asked for all of our systems to create false particles on Earth to give us the equivalency, but bottom line, now in 2019 when we're ready to push out into it, we need to find the actual. So this was the first attempt. Now Parker probe with digital capabilities, gamma ray technology, 5G communication systems, this thing is going to be able to do what Parker's going to be able to do what this could not. So when they say that the Parker probe is going to touch the sun's atmosphere, what they mean is the plasmasphere, the exact same place that the Genesis probe was sent off to touch and failed at. But now we have gamma communication systems and we've launched it and it is so far being successful. We are now touching the sun's atmosphere. Now what is that? Here is a representation of the sun's atmosphere within Earth's magnetosphere. It's the closest that we can get to outside of Earth's atmospheric layers. Still within the magnetosphere where we can study, because it's not outside of the bow shock, outside of the magnetosphere, all of our heliophysics satellites and measurement tools are found within them, and there's a reason for that, but that's for another video. So, right now the Parker probe is about 6,000 miles up at the end of the exosphere. Now, it doesn't have to worry about the ionosphere and any of the metabolic structures that are causing anomalies that we can't fully explain. At 6,000 miles up in the plasmasphere, this graphic, which NASA doesn't have one for the plasmasphere, this is the magnetosheath. However, this turbulent plasma environment is found exactly right here in the plasmasphere, and that is where this Parker probe is flying off to because it's going to get a raw particle from the sun's atmosphere, because 1% of this 100% of the mass is found within the Earth's magnetosphere above Earth's atmosphere. And so we can't find it here in Earth's atmosphere, but we can't actually maintain anything out here. The Parker probe, like other heliophysics satellites, THEMIS and MMS missions, and all of these are designed to go as far into the plasmasphere as possible to give us a theoretical idea as to how many layers and how far out we have to go, and if it ever gets any better, if there's ways to slip through it, if there's any times that it goes back towards and we can ride that, just anomalies that we might be able to use for our advantage. That's what these probes are for. That's where these probes go. Common sense and science back at 100%. Now, they had to sell this mission to Congress, and that's why they're saying million miles and millions away, because it's just got to be sold to get the money. They can't do the same thing they just failed at. NASA won't get the money, Congress won't approve it. The end. So common sense shows the Parker space probe is only going 6,000 miles up where the Genesis space probe went and failed to do the exact same thing that everyone on Earth is working to figure out, and that is radiation exposure to our tools and our astronauts.